Hello, everyone, and welcome back to class. I'm really excited to speak with you in our digital classroom. I see we are signed up for week 2 of the course. And so in week 2 of the course, we are going to be taking another layered approach on how should we start to think about anatomy and physiology as a subject. We're going to be doing this by taking a look first at experimental design and the scientific method. The reason is because anatomy and physiology is just another science course, and we need to be able to learn about conceptually how science is conducted. Because I think it's a really great way to understand how we experience a phenomena and be able to learn more about how scientists interpret that phenomena. I find that it's a great way because it's impactful for our local Potomac Highlands, but also the Appalachian region, where science education, it's a relatively untapped market. And so being able to do that helps us with what they call a intellectual currency exchange. And you've already been doing this, especially in last week when you worked on your reflection and discussion boards. You are taking the concept for the week and sharing it with me as much as I am sharing each week's concept with you. We're sharing our bodies of knowledge and how we're growing as anatomists. And this is really good because it helps affirm and grow your soft skills in this class. And then in the lab, we are going to concentrate more in our hard skills. And to do that, we are going to learn about homeostasis, one of the fundamental concepts found in physiology. And in order to make sense of the vast volume of information that becomes increasingly dependent on different approaches, we need to put a greater emphasis on traditional integrated and holistic approaches. Look at that big picture developed by scientists who gave birth to physiology as an intellectual discipline. Our understanding of physiological regulation has evolved over time from the Greek idea of what they call the body humors. The ancient Greeks thought our bodies were being humored by the different stimuli that they encounter in a day-to-day basis. And we're going to do this, and that idea grew all the way through to Claude Bernard's milieu interne, which is the internal response of our bodies, upwards into Walter Cannon's formulation of the concept of homeostasis and the application of control theory, where he looked at homeostasis as a feedback loop, positive or negative, and that he used that to explain how constant internal environments are achieved and that homeostasis becomes a central unifying concept of physiology, and it defines our field as biologists because all organisms have to maintain homeostasis or they cease to function. Homeostasis is not a static or unvarying. It's just a dynamic process that can change internal conditions as required to allow for the organism to survive external challenges. It's important to note that homeostatic regulation is not merely a product of a single negative feedback cycle, but reflects complex interaction of multiple feedback systems found within our body systems. And it can be modified by higher control centers, such as our nervous system. This hierarchical control and feedback redundancy results in finer level of control and greater flexibility as it enables the organism to then adapt to their environmental conditions. But at the end of the day, it's the health and vitality of the organism that can be used as an end result of homeostatic regulation. A understanding of normal physiology is not possible without the appreciation and acceptance of this concept. So that's why we need to learn about this most fundamental physiological cause and effect relationship. And we're going to do this by using an open educational resource as part of your experiment for the lab this week. And I'm going to go share it with you real quick. And so this is going to be our experiment for the week. It is the Body Control Center. And in this activity, it's actually up to you, not the body, to maintain homeostasis in a virtual person. So what that means is that you are going to be using the concepts found in experimental design and change the variables, the independent variables, to try and attempt to maintain homeostasis in a virtual person. Now, this is going to actually date me, but this lab assignment kind of reminds me of, back in the 90s to the early 2000s, virtual pets were all the rage. You had little Tamagotchi. I was actually had the one called a Digimon, which looked like a little T-Rex. And you would um, change their food, clean up after them, play with them, much like you would a real pet. But really you're changing independent variables to maintain homeostasis in that in the toy. But here we're going to be doing it virtually the same way, and the gauges will show current conditions in the body, and you will be moving the dial, such as decrease to increase, and your goal really is to watch the responses of these different variables. That's the main goal. And don't become complacent when you achieve a balance. This simulator is supposed to mimic our bodies. And our bodies are undergoing a lot of internal and external stimuli. And so homeostasis is not static. It's constantly ongoing. Checks and balances through multiple body systems are constantly occurring. So you may not be able to maintain homeostasis for an extended period of time, as random variables will randomly appear in your experiment, and you're going to have to address them. So that's why I want you to concentrate more on the dials. And so we can fire it up, and there is our virtual person. They've got low blood delivery, low oxygen. Blood pressure is okay. And body temperature is running a little high in glucose. But you'll notice on how these dials are changing, and the person is progressively becoming much worse. We can change in these different variables and hope to make our person survive. And as you can see, we did not maintain homeostasis. Our patient, unfortunately, has ceased function. And yeah, this will actually be your first patient this semester. But again, this is a physiological cause and effect relationship. So um, if you have any questions, please reach out. My office is in room 208, and you can always come in person, send me an email, or set up a video chat. All right. Good luck.